Welcome to week 3. Today we're going to cover force couple systems and we're going to do an example. So first of all, let's cover the definitions and equations. A couple is a system of forces with a resultant moment but no resultant force. That means you have two forces that are equivalent to each other in magnitude but are opposite in direction. So you can find the moment caused by a couple by taking the force of one of the couples, or of one of the forces, and multiplying it by the distance between the two forces. Also, let's say we have two forces, like this is a couple. We have a force going this way and another one going this way, and they both have the same magnitude. This is the perpendicular distance between the two forces. And to find the direction of the moment, all you have to do is curl your fingers in the direction of the forces, and your thumb would point in the direction of the moment. And this is the cause of rotation by the two forces. So this question asks us to determine the moment of the couple acting on the member shown. So here we have a beam sort of thing. The image is horrible, I'm sorry, but I really like this problem. Our couple forces are 150 kilonewtons and they're pointing in the exactly opposite directions. So the first thing I want to do is decompose the couples into x and y components, right? So we're going to have x and y component for both of them. So from there, all you have to do is take the 150 times 4/5 to get the x component, and that gives us 120. To get the y component, we just do 150 times 3/5, and that gives us 90 kilonewtons. And it's the exact same for both, right? The 4/5 gives us the x component, and the 3/5 gives us the y component. Okay, so this is what they look like when they're drawn in. You have the 90 going downwards, 120 this way, 120, 90. Make sure you're getting the directions correct. Once again, based on the original forces. So now we go to solve for the moment of the couple acting on the member. So we know that a moment is a force times a perpendicular distance. So there's two methods. The first method, we pin this member at point D. So we're going to be rotating about point D. So I start by moving from D outward. So let's look at the 90 kilonewton force. The 90 would push the member this way and cause it to rotate clockwise. So whenever we rotate clockwise, it's negative. So negative 90 kilonewtons times 2 meters, because that's the perpendicular distance from D to the 90 kilonewtons. So we have negative 90 times 2 plus 120 times 0. So we have the 120, but it's exactly parallel to point D. Thus, it wouldn't cause any moment at all. So we just consider this to not cause any moment. Then I move on to the 90 kilonewtons here. It seems like it's pushing upward this way, so it would cause a counterclockwise rotation about point D. So counterclockwise is always positive. And the perpendicular distance from D to 90 is 2 plus 3, 5 meters. So we have 90 times 5. And then finally we look at this 120 kilonewtons. So at first you might think, oh, it's parallel to point D. But no, it's not. It's actually 1 meter off of point D. So 120 kilonewtons is going to end up pushing this way, and it's going to cause a rotation that is counterclockwise. So it's also going to be positive. And the perpendicular distance to D is 1 meter. So 120 times 1, and once you sum all of these, you get 390 kilonewtons times meters. And because it's positive, we know that the overall rotation is going to be counterclockwise. So I feel like that's pretty straightforward. There's another way that we can solve for the moment about point D, or just about the entire member, and that's by using the moment of a couple. The moment of a couple is the force times the perpendicular distance between the couple. So here we have two different couples. We have the 90 and the 120. So let's look at the 90 first. 90, so we take the force 90 times the distance between the two 90s. and that distance is 3 meters, so 90 times 3. Now, is it going to be positive or negative? I put positive because if you follow the arrows in which the 90 kilonewtons are pointing, they're moving counterclockwise. So they're creating a counterclockwise rotation, and counterclockwise is always positive. If we look at the 120, we do 120 times their perpendicular distance, which is 1 meter. And then we look at which way they're rotating. So I'm following the arrows once again, and it looks like they're causing a counterclockwise rotation as well, which is positive. So we end up with 90 times 3 plus 120 times 1, and that gives us positive 390 kilonewtons per meters, counterclockwise once again. So either way, you get the exact same solution. This is, in my opinion, quicker. As long as you know your distances, you know your couples, you're good. So some tips and tricks: whenever you have a couple that's not directly parallel, that's not directly x or y, make sure you break it down into components. When you're finding the moment, make sure that you're using perpendicular distances. So if something is parallel to the point at which you're pinned, then it will not cause a moment. Only perpendicular forces will cause a moment. And then make sure that you know clockwise and counterclockwise. So if you're going counterclockwise, it's positive. If you're going clockwise, it's a negative rotation. And always remember your right hand rule. And that's pretty straightforward.